chapter 2 deals with research. One of the interesting things about research, you wouldn't have most scientific endeavors only exist because we can do scientific experiments in order to uh, show how they work, to see how the world works. We need to show that over and over again we get the same results. Psychology is a science. It's a tough one. It's a tough science because the reality is that different cultures will have different results. Uh, there are very few universal um, laws that actually cover psychology, and so that's what we're actually talking about. And in order for us to say anything about psychology, we need research to back us up. So that's what we're going to talk about today. We're going to talk about research. So let's go ahead and get started. Okay. Scientific research is a critical tool of successfully navigating our complex world, especially for psychologists. Without it, we would be forced to rely solely on intuition, other people's authority, and blind luck. While many of us feel confident in our abilities to decipher and interact with the world around us, history is filled with examples of how very wrong we can be when we fail to recognize the need for evidence to support in supporting our claims. At various times in history, we would have been certain that the sun revolved around a flat earth, that the earth's continents did not move, and that mental illness was caused by possession. And of course, if you go back in history, that's what they thought. They thought that people that were having problems with mental health, they thought that they were possessed by demons. It is through systematic scientific research that we divest ourselves of our preconceived notions and superstitions and gain an objective understanding of ourselves and our world. Scientific knowledge is advanced through a process known as the scientific method. Basically, ideas in the form of theories and hypotheses are tested against the real world in the form of empirical observations, and those empirical observations lead to more ideas that are tested against the real world, and so on. In this sense, the scientific process is circular. So we come up with a hypothesis, we create a question, an observable question, then we observe it, we come up with a conclusion. Oh, we've gone backwards, haven't we? Sorry. We come up with a hypothesis. We have a question. Okay, let's start here. We have a question, and then we develop a hypothesis. We create an experiment for that hypothesis. This isn't right. We need observe before conclusion. Anyway, that's the scientific method. The types of reasoning within the circle are called deductive and inductive. In deductive reasoning, ideas are tested in the real world. In inductive reasoning, real world observations lead to a new idea. In the scientific context, deductive reasoning begins with a generalization, one hypothesis, that is then used to reach logical conclusions about the real world. If the hypothesis is correct, then the logical conclusions reached through deductive reasoning should also be correct. Inductive reasoning uses empirical observations to construct broad generalizations. Conclusions drawn from inductive reasoning may or may not be correct, regardless of the observations on which they are based. Scientists use inductive reasoning to formulate theories, which in turn generate hypotheses that are tested with deductive reasoning. So we start with inductive reasoning, we start with a general idea, and we go to a specific idea. With deductive reasoning, we have a specific observation, and then we look to see if it fits in the general idea of the real world. A theory is a well-developed set of ideas that propose an explanation for observed phenomena. Theories are repeatedly checked against the world, but they tend to be too complex to be tested all at once. Instead, researchers create hypotheses to test specific aspects of a theory. A hypothesis is a testable prediction about how the world will behave if our idea is correct, and it is often worded as an if-then statement. If I study all night, I will get a passing grade on the test. The hypothesis is extremely important because it bridges the gap between the realm of ideas and the real world. As specific hypotheses are tested, theories are modified and refined to reflect and incorporate the result of these tests. You've heard the old wives' tale, are women really attracted to men who have an edge and reject nice guys? Nice guys finish last. A study by a group from Texas A&M University used three interlocking studies to discover whether women found male dominance attractive. The theory: women are attracted to dominant men. Results from the three studies showed that women were more attracted to men who were more altruistic than ones who were more dominant. However, women found men who were more dominant as more sexual and more physically attractive than men who were not dominant. Do nice guys finish last? Evidently, while women find dominant men more attractive, it is nice guys they would rather be around. Research from 1988 by David Buss indicates that women respond more readily to men who are more dominant and display their attributes more readily. So which is more accurate, the research in 1988 from Michigan, that's where David Buss was, or the research from 1995 in Texas? Did things change between 1988 and 1995? I guess that's the question. And there is no answer. We can continue to ask this question throughout the ages, and we would get different answers in different eras. Because we're human, and humans do change, attitudes change, and that's really what we're measuring here. With whether women are more attracted to dominant men or altruistic men. A scientific hypothesis is also falsifiable or capable of being shown to be incorrect. Sigmund Freud had lots of interesting ideas to explain various human behaviors. However, a major criticism of Freud's theories is that many of his ideas are not falsifiable. Despite this, Freud's theories are widely taught in introductory psychology texts because of their historical significance for personality psychology and psychotherapy. And these remain the root of all modern forms of therapy. As a matter of fact, if we look at, and of course we're not going to do that right now, but if we look at Freud, what we realize is that psychotherapy was the first technique used to treat people with mental illness. And most of the techniques that came after that were arguing with Freud, were trying to fix Freud. So Freud was always a focus of the individuals coming up with new techniques. So if we don't study Freud, we don't understand where these other techniques came from. There are many research methods available to psychologists in their efforts to understand, describe, and explain behavior and the cognitive and biological processes that underlie it. Some methods rely on observational techniques. Other approaches involve interactions between the researcher and the individuals who are being studied, ranging from a series of simple questions to extensive in-depth interviews to well-controlled experiments. Each of these research methods has unique strengths and weaknesses, and each method may only be appropriate for certain types of research questions. Correlational research can find a relationship between two variables, but the only way a researcher can claim that the relationship between the variables is cause and effect is to perform an experiment. In experimental research, there is a tremendous amount of control over variables of interest. While this is a powerful approach, experiments are often conducted in very artificial settings. This calls into question the validity of experimental findings and how they would apply in real-world settings. In observational research, scientists are conducting a clinical or case study when they focus on one person or just a few individuals. When they focus their attention on a very small number of people, they can gain a tremendous amount of insight into those cases. If scientists ultimately want to explain all behavior, focusing attention on such a special group of people can make it difficult to generalize any observations to the larger population as a whole. This is an interesting case. This individual was kept tied to a potty chair in the attic of her parents' house, and no one discovered her for 12 years. They didn't talk to her. They didn't let her move. And the problem was, well, of course, there was a fairly serious problem. So when she was found, they took her away from her parents, and they tried to teach her how to interact in society. And what happened was she had a difficult time moving, she had a difficult time walking, and she never really learned to speak coherently because she didn't learn to speak before she was old enough. In that time frame when she was supposed to learn language, she didn't learn it, and because of that, she had a difficult time speaking. Generalizing refers to the ability to apply, and of course, this is a case study. They tried to help this little girl. They tried to see if she would become as normal as possible. And as it turned out, they never were able to get her to communicate properly or to move in a normal fashion. She tended to hop like a rabbit. Generalizing refers to the ability to apply the findings of a particular research project to larger segments of society. Case studies provide enormous amounts of information, but since the cases are so specific, the potential to apply what's learned to the average person may be very limited. One of the best ways to gain information is to simply observe the behavior in its natural context. However, people might change their behavior in unexpected ways if they know that they are being observed. It is critical that the observer be as unobtrusive and as inconspicuous as possible. When people know that they're being watched, they are less likely to behave naturally. And this is true of animals as well. Jane Goodall, who died last year, researched chimpanzees for decades, and it took her. She was observing them, and she assumed that why would the chimpanzees care if I watched them? But it took she observed them for 12 years before she saw any violent behavior. They were acting differently around her. Chimpanzees have naturally can have a mean streak, and but she never observed it. So when she first started observing chimpanzees, the thought was that chimpanzees were these hyper beings where violence didn't occur. But as it turned out, of course, they were just not showing her any of of the violence from that they wanted to show, or they needed to show. Turned out that rape was not that uncommon, that they would routinely tear monkeys apart and eat the meat. She thought they were all vegetarian because that's all she ever saw them eating is fauna and not any, or flora and not any fauna. The greatest benefit of naturalistic observation is the validity or accuracy of information collected unobtrusively in a natural setting. Having individuals behave as they normally would in a given situation means that we have a higher degree of ecological validity or realism than we might achieve with other research approaches. Therefore, our ability to generalize the findings of the research to real-world situations is enhanced. Should be able to see the deer right there. A potential problem in observational research is observer bias. Generally, people who act as observers are closely involved in the research project and may unconsciously skew their observations to fit their research goals or expectations. To combat this, researchers often compare observations of the same event by multiple observers in order to test inter-rater reliability, a measure of reliability that assesses the consistency of observations by different observers. Often psychologists develop surveys as a means of gathering data. Surveys are lists of questions to be answered by research participants and can be delivered as paper and pencil questionnaires administered electronically or conducted verbally. Generally, the survey itself can be completed in a short time, and the ease of administering a survey makes it easy to collect data from a large number of people. And when I did my dissertation, I had to do original research, and that's what I did. I did surveys. Surveys allow researchers to gather data from larger samples than may be afforded by other research methods. A sample is a subset of individuals selected from a population, which is the overall group of individuals that the researchers are interested in. Researchers study the sample and seek to generalize their findings to the population. Researchers will begin this process by calculating various measures of central tendency from the data they have collected. These measures provide an overall summary of what a typical response looks like. There are three measures of central tendency: mode, median, and mean. The mode is the most frequently occurring response. In this group, it is the number 5. So 5 is the mode. The median lies at the middle of a given data set, and here is our group of numbers, and right in the middle is the number 9. The mean is the arithmetic average of all data points, and that's just the average. So you add all the numbers up, 7, 9, 5, and 3. You add them up, you get 24. There are 4 numbers that you are dealing with, so 4 divided into 24 is 6. So 6 is your mean. That is your average. There's both strength and weakness of the survey in comparison of case studies. By using surveys, we can collect information from a larger sample of people. A larger sample is better able to reflect the actual diversity of the population, thus allowing better generalizability. Therefore, if our sample is sufficiently large and diverse, we can assume that the data we collect from the survey can be generalized to the larger population with more certainty than the information collected through a case study. However, given the greater number of people involved, we're not able to collect the same depth of information on each person that would be collected in a case study. Another potential weakness of surveys is that people don't always give accurate responses. They may lie, misremember, or answer questions in a way that they think makes them look good. For example, people may report drinking less alcohol than is actually the case. I only had a couple. I worked in the emergency room, and it wouldn't matter how drunk somebody was. You'd ask them, well, how much did you drink? And they'd say, I only had a couple of beers. It was standard. They only had a couple. But how much is a couple? I don't know, a case? Some researchers gain access to large amounts of data without interacting with a single research participant. Instead, they use existing records to answer various research questions. This type of research approach is known as archival research. Archival research relies on looking at past records or data sets to look for interesting patterns of or relationships. The researcher employing archival research never directly interacts with the research participant. Therefore, the investment of time and money to collect data is considerably less with archival research. Additionally, researchers have no control over what information was originally collected. Therefore, research questions have to be tailored so that they can be answered within the structure of the existing data sets. There is also no guarantee of consistency between the records from one source to another, which might make comparing and contrasting different data sets problematic. When we test the same group of individuals repeatedly over an extended period of time, we're conducting longitudinal research. Longitudinal research is a research design in which data gathering is administered repeatedly over an extended period of time, longitudinal. In cross-sectional research, a researcher compares multiple segments of the population at the same time. The researcher directly compares different groups of people by age instead of studying a group of people over 20 years. The researcher would compare 20-year-old individuals with a group of 30-year-old individuals and a group of 40-year-old individuals. Statistics show that when people buy ice cream, more crimes are likely to occur. When ice cream sales rise, crime rates rise. Does buying ice cream cause crime? There is little correlation between the two. Crime increases when it is hot, as does ice cream sales. And interestingly, this guy stole an ice cream truck. And that was his crime. Correlation means that there is a relationship between two or more variables, but this relationship does not necessarily imply cause and effect. When two variables are correlated, it simply means that as one variable changes, so does the other. We can measure correlation by calculating a statistic known as a correlation coefficient. A correlation coefficient is a number from -1 to +1 that indicates the strength and direction of the relationship between variables. The correlation coefficient is usually represented by a letter R. The number portion of the correlation coefficient indicates the strength of the relationship. The closer to the number is to 1, be it negative or positive, the more strongly related the variables are, and the more predictable changes in one variable will be as the other variable changes. The closer the number is to 0, the weaker the relationship, and the less predictable the relationships between the variables become. For instance, a correlation coefficient of 0.9 indicates a far stronger relationship than a correlation coefficient of 0.3. If the variables are not related to one another at all, the correlation coefficient will be 0. The sign positive or negative of the correlation coefficient indicates the direction of the relationship. A positive correlation means that the variables move in the same direction. Put another way, it means that as one variable increases, so does the other. And conversely, when one variable decreases, so does the other. A negative correlation means that the variables move in opposite directions. If two variables are negatively correlated, a decrease in one variable is associated with an increase in the other and vice versa. Correlations can be predictive values, can have predictive value. There is a positive correlation between an individual's height and their weight. A negative correlation exists between someone's tiredness during the day and the number of hours they slept the previous night. The amount of sleep decreases as the feelings of tiredness increase. We find no correlation between hours of sleep and shoe size. Positive correlation, negative correlation. Shoe size. That's kind of interesting because I just looked this up. The average shoe size for males in the United States is 10 and a half. The average height for males in the United States is 5'10". However, I'm an outlier. I have I wear size 12 shoes, so I have a foot that's larger than the average, and I'm only 5'6", so I'm 4 inches shorter than the average male in the United States. How weird! So I'm an anomaly. Correlation is limited because establishing the existence of a relationship tells us little about cause and effect. While variables are sometimes correlated because one does cause the other, it could also be the same that some other factor, a confounding variable, is actually causing the systematic movement in our variables of interest. In the ice cream crime rate example mentioned earlier, temperature is a confounding variable that could account for the relationship between the two variables. The temptation to make erroneous cause and effect statements based on correlational research is not the only way that we tend to misinterpret data. We also tend to make the mistake of illusory correlations, especially with unsystematic observations. Illusory correlations or false correlations occur when people believe that relationships exist between two things when no such relationship exists. Why are we so apt to believe in illusory correlations like this? Often we read or hear about them and simply accept the information as valid. Or we have a hunch about how something works and then look for evidence to support that hunch, ignoring evidence that would tell us our hunch is false. This is known as confirmation bias. Other times, we find illusory correlations based on the information that comes most easily to mind, even if the information is severely limited. In the scientific context, an experiment has precise requirements for design and implementation. In order to conduct an experiment, a researcher must have a specific hypothesis to be tested. And hypotheses can be formulated either through direct observation of the real world or after careful review of previous research. Personal observations are what often lead us to formulate a specific hypothesis, but we cannot use limited personal observations and anecdotal evidence to rigorously test our hypothesis. Instead, to find out if real-world data supports our hypothesis, we have to conduct an experiment. The most basic experimental design involves two groups, the experimental group and the control group. The two groups are designed to be the same except for one difference, experimental manipulation. The experimental group gets the experimental manipulation, that is, the treatment or the variable being tested, and the control group does not. Since experimental manipulation is the only difference between the experimental and control groups, we can be sure that any differences between the two are due to experimental manipulation rather than chance. We also need to precisely define our operationalize. We also need to precisely define our operationalize how we measure our variable. Operationalize. I'm sorry, I didn't look at this before I started reading it. An operational definition is a precise description of our variables, and it is important in allowing others to understand exactly how and what a researcher measures in a particular experiment. This aids people's ability to interpret our data as well as their capacity to repeat our experiment should they choose to do so. Ideally, the people who score the tests are unaware of who was assigned to the experimental or control group in order to control their experimenter bias. Experimenter bias refers to the possibility that a researcher's expectations might skew the results of the study. I have several different degrees. One of mine degrees is as a medical laboratory technician. Um, we were doing experiments trying to determine what type of antibiotics was better for um, was better for otitis media. That's ear infections. So what we did, we treated the individual with we gave the individuals different types of antibiotics, but we didn't know what type of antibiotics we were giving them to see if they worked. But we didn't know which ones were working. Of course, we were doing the experiment for a pharmaceutical company, and the pharmaceutical company wanted us wanted their antibiotic to work better than the other antibiotic. As it turned out, all the antibiotics worked. So there you go. We were using specific antibiotics that were targeted for that bacteria. We were also using broad spectrum antibiotics that were um, could work on different types of bacteria. And that was the idea. The idea was that we were treating them with antibiotics, but we were treating them with specific antibiotics and with broad spectrum antibiotics. And we had no idea which one was which. If the observers know who is in which group, it might influence how they interpret ambiguous responses. And this was a problem. This is one of the reasons why we were doing it. I was working in a children's clinic and a pediatrics clinic in Virginia. And the reason we were doing it instead of the pharmaceutical company is because the pharmaceutical company would cheat. We knew that. And we were looking for good antibiotics. If the observer doesn't know, by being blind to who is in which group, the researchers are protected against bias. And so this is the type of research we did. It was a single blind test. So not only did in our case, it was a double blind because not only did the individual not know what antibiotic they were getting, but we didn't know either. That so the patient was blind, and so was the doctor. In a single blind, the doctor knows, but the patients don't. In a double blind test, neither of them knows. This situation is a single blind study where the doctor knows and the patient doesn't, meaning that one of the groups, the participants, are unaware as to which group they are in, the experimental or control group, while the researcher who developed the experiment knows which participants are in each group. In a double-blind study, both the researchers and the participants are blind to group assignments. By doing so, we can control for both experimenter and participant expectations. The placebo effect occurs when people's expectations or beliefs influence or determine their experience in a given situation. In other words, simply expecting something to happen can actually make it happen. Placebos actually work. Now, how in the world does this work? Is it mind over matter? Well, actually, what happens is if you've got pain and you take a pill, and the pill doesn't actually have anything to do with your pain, but the pain goes away. What has happened? Well, what has happened is your body has adapted. It has changed. It has increased the pain relieving biochemicals in your brain to make the pain go away. And this happens more than you know. So maybe the pharmaceuticals are all placebo effects. Probably not. But very frequently we do see this where somebody takes a pill and the pain goes away. And you can think of it this way: if you have headaches, I don't ever have headaches, so this wouldn't work on me. But if you were talking about somebody having a headache and they took an aspirin and within 3 or 4 minutes the pain went away. We see this all the time. The reality is, if you take an aspirin or acetaminophen or ibuprofen, if you take any medication to make the pain go away, it has to get into your stomach, then it has to be metabolized, and then it should get into your system enough to make the pain go away. It should take about 20 minutes for you to digest the medication and for the pain to go away. But usually the pain goes away within minutes rather than 20 minutes. In a research experiment, we strive to study whether changes in one thing causes changes in another. To achieve this, we must pay attention to two important variables, or things that can be changed in any experimental study: the independent variable and the dependent variable. An independent variable is manipulated or controlled by the experimenter. In a well-designed experimental study, the independent variable is the only important difference between the experimental and the control groups. A dependent variable is what the researcher measures to see how much effect the independent variable has. So let me go through my dissertation, what type of experiment I was doing. I was looking for resilience. I wanted to measure resilience, and I had a survey that measured resilience. But I wanted to see whether age affected resilience. Were older people more resilient than younger people? I wanted to see if trauma affected how much trauma you had in your life, if that affected your resilience level. I wanted to see education, whether education changed your resilience level. The more educated you were, the more resilient you were. I wanted to see if males were more resilient than females, or females were more resilient than males. That's four. And the fifth one had to do with culture. I wanted to see if a stronger culture, adherence to your culture, made you more resilient or not. And so that was my experiment. So I gave them 3 surveys, and I asked them questions. Well, I didn't have to give them a survey to find out if they were male or female, of course, and they gave me how many years of education they had had. Okay, then I had 3 different surveys, didn't I? Yeah, I had a survey that measured culture, I had a survey that measured trauma, and I had a survey that measured resilience. There you go. Okay, interesting research. Are women more resilient than males? Now that our study is designed, we need to obtain a sample of individuals to include in the experiment. We need to determine who to include. Participants are the subjects of the psychological research. Individuals who are involved in psychological research actively participate in the process. Often psychological research projects rely on college students to serve as participants. The vast majority of research in psychological subfields has historically involved students as research participants. But are college students truly representative of the general population? College students tend to be younger, more educated, more liberal, and less diverse than the general population. Although using students as test subjects is an accepted practice, relying on such a limited pool of research participants can be problematic because it is difficult to generalize findings to the larger population. If possible, a random sample should be used. A random sample is a subset of a larger population in which every member of the population has an equal chance of being selected. Random samples are preferred because if the sample is large enough, we can be reasonably sure that the participating individuals are representative of the larger population. This means that participants are percentages of characteristics in the sample, sex, ethnicity, socioeconomic level, and any other characteristics that might affect the results are close to those percentages in the larger population. The next step of the experimental process is to split the participants into experimental and control groups through random assignment. With random assignment, all participants have an equal chance of being assigned to either group. Random assignment is critical for sound experimental design. With sufficiently large samples, random assignment makes it unlikely that there are differences between the groups. It would be very unlikely that we would get one group composed entirely of males or a given religious ideology. This is important because if the groups are systematically different before the experiment began, we would not know the origin of any differences we find between the groups. Were the differences pre-existing or were they caused by the manipulation of the independent variable? Random assignment allows us to assume that any differences observed between experimental and control groups result from the manipulation of the independent variable. True experiments require the experimenter to manipulate an independent variable, and that can complicate many questions that psychologists might want to address. We categorize this type of research approach as quasi-experimental and recognize that we cannot make cause and effect claims in these circumstances. Experimenters are also limited by ethical constraints. Once data is collected from both the experimental and the control groups, a statistical analysis is conducted to find out if there are meaningful differences between the two groups. A statistical analysis determines how likely any difference found is due to chance, and thus not meaningful. Generally, psychologists consider differences to be statistically significant if there is less than a 5% chance of observing them if the groups did not actually differ from one another. Stated another way, psychologists want to limit the chances of making false positive claims to 5% or less. There you go. It has to do with 5%. The greatest strength of experiments is the ability to assert that any significant differences in the findings are caused by the independent variable. This occurs because random selection, random assignment, and a design that limits the effects of both experimenter bias and the participant expectancy should create groups that are similar in composition and treatment. Therefore, any difference between the groups is attributable to the independent variable, and now we can finally make a causal statement. When psychologists complete a research project, they generally want to share their findings with other scientists. The American Psychological Association, the APA, publishes a manual detailing how to write a paper for submission to scientific journals. Scientific journals generally publish peer-reviewed journal articles aimed at an audience of professionals and scholars who are actively involved in research themselves. Peer review provides some degree of quality control for psychological research. Poorly conceived or executed studies can be weeded out, and even well-designed research can be improved by the revisions suggested. Peer review also ensures that the research is described clearly enough to allow other scientists to replicate it, meaning that they can repeat the experiment using different samples to determine reliability. Reliability and validity are two important considerations that must be made with any type of data collection. Reliability refers to the ability to consistently produce a given result. In the context of psychological research, this would mean that any instruments or tools used to collect data do so in consistent, reproducible ways. There are a number of different types of reliability. Inter-rater reliability, the degree of which two or more different observers agree on what has been observed. Internal consistency, the degree to which different items on a survey that measure the same thing correlate with one another. Retest reliability, the degree to which the outcomes of a particular measure remain consistent over multiple administrations. Unfortunately, being consistent in measurement does not necessarily mean that you have measured something correctly. This is where validity comes into play. Validity refers to the extent to which a given instrument or tool accurately measures what it's supposed to measure, and there are a number of ways in which validity can be expressed. Ecological validity, the degree to which research results generalized to real-world applications. Construct validity, the degree to which a given variable actually captures or measures what it is intended to measure. And face validity, the degree to which a given variable seems valid on the surface. While any valid measure is reliable, the reverse is not necessarily true. Today, scientists agree that good research is ethical in nature and is guided by a basic respect for human dignity and safety. Modern researchers must demonstrate that the research they perform is ethically sound. Any experiment involving the participation of human subjects is governed by extensive, strict guidelines designed to ensure that the experiment does not result in harm. Any research institution that receives federal support for research involving human participants must have access to an Institutional Review Board, or IRB. The IRB is a committee of individuals often made up of members of the institution's administration, scientists, and community members. The purpose of the IRB is to review proposals for research that involves human participants. The IRB reviews these proposals with the principles mentioned above in mind, and generally approval from the IRB is required in order for the experiment to proceed. An institution's IRB requires several components in any experiment it approves. Each participant must sign an informed consent form before they can participate in the experiment. An informed consent form provides a written description of what participants can expect during the experiment, including potential risks and implications of the research. It also lets participants know that their involvement is completely voluntary and can be discontinued without penalty at any time. The informed consent guarantees that any data collected in the experiment will remain completely confidential. In cases where research participants are under the age of 18, the parents or legal guardians are required to sign the informed consent form. While the informed consent form should be as honest as possible in describing exactly what participants will be doing, sometimes deception is necessary to prevent participants' knowledge of the exact research question from affecting the results of the study. Deception involves purposely misleading experiment participants in order to maintain the integrity of the experiment, but not to the point where the deception could be considered harmful. Many psychologists conduct research involving animal subjects. Often these researchers use rodents or birds as the subjects of their experiments. The APA estimates that 90% of all animal research in psychology uses these species. The human and ethical treatment of animal research subjects is a critical aspect of this type of research. Researchers must design their experiments to minimize any pain or distress experienced by animals serving as research subjects. Whereas IRBs review research proposals that involve human participants, animal experimental proposals are reviewed by an Institutional Animal Care and Use Committee, the IACUC. And that is it. There you go. So you might be wondering, you might be wondering about my research. What did I find out? Did age have anything to do with resilience? Did gender have anything to do with resilience? Trauma, did it have anything to do with resilience? Did education have anything to do with resilience? I was working with an indigenous population in Montana. That's where this shirt comes from. Niwa's run. Niwa is Lakota. I'm sorry, Nakota. It's also Lakota. It means grandmother's run, is what it means. Okay. Okay, so I was working with an indigenous group in Montana, and what I discovered was age had nothing to do with resilience. Education had nothing to do with resilience. The amount of trauma you suffered throughout your life didn't have anything to do with resilience. Education didn't have anything to do with resilience. The one thing that did have to do with resilience was culture. The more you adhered to your culture, the more resilient that you were, as curious as that is. And I'll tell you what, there's a synopsis. They did a synopsis of my research, and I can put that, I'll put that on the website so you guys can see it. Okay, I'll see you next week.